Welcome to our channel. If this is your first time, please subscribe and like this video so you can keep getting more content. In a world where machines are increasingly becoming part of our daily lives, the question of how artificial intelligence thinks has captured the imagination of many. Picture a scenario. You're chatting with a virtual assistant, and it seems to understand your requests almost intuitively. You ask it to set a reminder for your friend's birthday, and it not only does that, but also suggests a gift based on your friend's recent interests. How does it know? What goes on behind the curtain of this digital wizardry? The answer lies in the intricate web of algorithms and machine learning that form the backbone of AI technology. If you've ever been curious about the magic behind AI, get ready for a deep dive into its inner workings. At its core, artificial intelligence is a collection of algorithms designed to mimic cognitive functions that humans associate with the human mind. These algorithms are mathematical formulas that take in data, process it, and produce outputs. The most fundamental aspect of AI is its ability to learn from data, a process known as machine learning. But how does this learning occur? Machine learning can be thought of as a subset of AI that enables systems to learn from data and improve their performance over time without being explicitly programmed. Imagine teaching a child to recognize animals. You show them pictures of cats and dogs, labeling each one. Over time, the child learns the distinguishing features of each animal. This is similar to how machine learning operates. Data is fed into the system, and the AI uses this data to identify patterns and make decisions. The first step in this process is data collection. In the age of big data, the volume of information available is staggering. From social media interactions to online purchases, every click and interaction generates data. For AI to think, it requires vast amounts of this data to train on. The more data it has, the better it can learn. This data is then cleaned and prepared, a process that involves removing inaccuracies and ensuring consistency. This preparation is critical because the quality of the data directly influences the AI's ability to learn effectively. Once the data is ready, the next step involves selecting an appropriate algorithm. There are various types of algorithms, each suited for different tasks. Supervised learning, for instance, is where the AI is trained on labeled data, meaning the input data is paired with the correct output. This method is commonly used in applications such as image recognition, where a model is trained on thousands of images labeled with their respective categories. The algorithm learns to associate certain features with specific labels, allowing it to make predictions on new, unseen data. An example of supervised learning is email spam filters that learn to distinguish between spam and genuine emails. On the other hand, unsupervised learning involves training the AI on data without explicit labels. Here, the algorithm must find patterns and relationships within the data itself. This is akin to a child exploring a new environment without guidance, discovering the world through observation and interaction. Clustering algorithms, for example, can group similar data points together, revealing hidden structures within the dataset. This approach is often utilized in customer segmentation, where businesses analyze purchasing behavior to identify distinct groups of consumers. A good example would be recommendation engines, like Netflix or YouTube, that predict user preferences. Another fascinating area within machine learning is reinforcement learning. This method draws inspiration from behavioral psychology, where an agent learns to make decisions by receiving rewards or penalties based on its actions. Imagine a game where an AI controls a character navigating a maze. Each time the character takes a step closer to the exit, it receives a reward. Conversely, if it hits a wall, it faces a penalty. Over time, the AI learns the best path to take, optimizing its strategy based on past experiences. This type of learning is particularly powerful in dynamic environments, such as robotics and game playing. An example of such includes self-driving cars learning to navigate by constantly adjusting based on feedback. The true magic of AI lies in neural networks, particularly deep learning, which is a more complex form of machine learning. Neural networks are inspired by the human brain's structure, consisting of interconnected nodes, or neurons, that process information. In a deep learning model, multiple layers of these neurons work together to analyze data. The first layer might recognize simple features, like edges in an image, while deeper layers combine these features to identify more complex shapes, such as faces or objects. This hierarchical learning allows deep learning models to achieve remarkable accuracy in tasks like speech recognition and natural language processing. However, the journey of AI decision-making is not without challenges. One significant issue is the concept of bias in AI. Since machine learning algorithms learn from historical data, they can inadvertently inherit the biases present in that data. For instance, if an AI system is trained on data that reflects societal prejudices, it may produce biased outcomes, leading to unfair treatment in areas like hiring or law enforcement. Addressing bias is a critical area of research, requiring continuous efforts to ensure that AI systems are fair and equitable. Transparency is another key concern in AI technology. Many advanced algorithms, particularly deep learning models, operate as black boxes. This means that while they can generate accurate predictions, understanding the rationale behind those predictions can be challenging. This lack of interpretability raises questions about accountability, especially in high-stakes applications such as healthcare or criminal justice. Researchers are actively working on methods to make AI systems more interpretable, shedding light on their decision-making processes. As we stand on the brink of an AI-driven future, the implications of this technology are profound. From enhancing productivity in industries to transforming the way we interact with machines, the potential is vast. However, with great power comes great responsibility. It is imperative to navigate the ethical landscape of AI thoughtfully, ensuring that these systems serve humanity positively and inclusively. In conclusion, artificial intelligence does not think in the way humans do, but it processes information and learns from data in remarkably sophisticated ways. Through algorithms, machine learning, and neural networks, AI systems can analyze vast amounts of information, recognize patterns, and make decisions. As we continue to explore the capabilities of AI, understanding the underlying mechanisms will empower us to harness this technology responsibly, paving the way for a future where humans and machines collaborate harmoniously. The secrets behind AI technology are not just about algorithms. They are about the potential to reshape our world, one decision at a time. What did you learn from this video? Comment and share your opinion down below. Don't forget to subscribe for more informative videos.